Hey guys, welcome to a new video. Pattern recognition forensics dental identification is exactly like what it sounds like. It's a very good scientific way to identify unknown people. They simply match teeth up to the impression, and in court, this is good enough to solve cases. Well, why isn't it good enough for plate tectonics? And the reason I ask this is because I've been working a lot on another video that's stressing me out. But it's so worth it when it's done. But anyways, what's so hard about noticing certain things, like recognizing these patterns going from small to large in an arch, and they actually look like bite marks, but they're not bite marks, but they are patterns that can be recognized and matched up with other features around the world. When you got one right over here that goes from small to big in the same arch manner, and it looks like a bite mark. It's not a bite mark, but it's these are islands, and over here are not islands, but they are part of this river complex right here. And what happens if I take this image and I overlay it with this image? Well, like this. You can see that as I bring it in, it's already starting to line up. But how well will it line up? That's what I want to know. You'd think that scientists would want to know too, but apparently they're not interested in things like this. They'd rather just believe what they're told and stick with it. But as you can see, this bite pattern matches. And then of course we can get as close as we need to. That's why I made these extra large. I mean, the first alarming thing would be the fact that they're matching the same pattern, the going from small to and getting larger in an arch. But then when they match the distancing here, it makes you wonder, why don't they notice this? Because what this is saying is this is an identification. This is placing these two images at the same scene. They're saying that forensically these images are from the same process. But there's a problem. In plate tectonics, there's no way to account for this. In plate tectonics, you can't just simply take this and overlay it and match it up, because then you'd have to explain how it was over there to begin with. And if you have plates, boundaries in between these two, or just features or land masses, plate tectonics can't go that far. It ends right there. And rather than come up with maybe that plate tectonics isn't that accurate, they just ignore it, right? Or maybe they don't even, maybe I'm the first person on this planet that just happened to notice that these two images look the same. I don't think that's possible, but maybe that's the case. Because other than that, then that would mean that people would be ignoring this similarity. I mean, really, think about this. It's one thing that they look alike, but when I match them up forensically and they line up like teeth from a crime scene, well, it makes you wonder what's going on. It should be like a red flag saying that our current accepted science about our planet is inaccurate and lacks the ability to explain features that I can easily find and show you in videos. I'm just a regular guy. I'm just a regular guy with Google Earth. But I have enough critical thinking to realize that these two areas look too much alike and that somehow it has to be explained why they match up, whether it's a coincidence or not. But I'd sure like to see someone try to prove that this is a coincidence. That would make my day. I just don't like believing things that are not accurate. And I would think you would too. Okay, I just want to go over these areas really quickly with you just to see if there's anything else I need to say. Okay, so I think one of them would be, I'm looking at this area right here and maybe above it, I'm not sure. I'm looking for other, see, that's what I do. I don't just throw this on there and go, okay, it's close enough. I kind of want to look for other things that would also support that these two areas are related. And when I take that second feature and match it there, it's like a second bite mark that's matching up. And it even seems to, well, let me see, let me look. Let's see what this is showing. I mean, look at the kind of the angles here. It actually looks like I need to rotate this there like that. And it's the placement of these islands with the outline of these river features. It just gives it that they're related. I mean, they're related by a process that created them. I'm not saying that these islands made this area. I'm saying what made the islands, or the energy that has been released in these islands, is also responsible for these features inside the continent. And it doesn't take much to realize that this is something. This is not somebody on YouTube that just finds patterns in everything he sees and thinks that everything's related. I'm showing you that they're related. This is more than my opinion. I'm showing you that they're related. And that's more than an opinion. This is observable evidence, is actually what it would be called in science. But science doesn't look at that stuff anymore. The science that we get invents things like black holes, dark energy, and then everything that they see from then on becomes related somehow to that. But look, come on. I mean, it's almost too simple. Like, it's too easy, but yet it's the most difficult thing I've ever experienced trying to convince people of. And I don't understand why. It's like, this is a no-brainer right here. Right now, anybody that studies the planet should be scratching their head, wondering why those line up. But instead, they'll ignore it because plate tectonics doesn't support that. And that doesn't make sense to me. Thanks for watching.